Okay, hello guys, so we are back again with another evening session of grade 10 maths paper 2. We are still having fun with analytical geometry and trigonometry. Okay, we've been having some good sessions so far. All right, I know some people are only writing paper 2 like tomorrow, on Wednesday. Right, there's some people are writing paper 2 on Wednesday, some are writing next week, so there's different times and dates and stuff like that where people are writing. So yeah, we just continue our war against the trig though. Okay, and hopefully you guys are good to be here. If we can just double tap on the screen, guys, and get the likes up, if we can, that would be much appreciated. Share the live to as many people as you possibly can that may need to be here for analytical geometry and trig. And yeah, welcome. So guys, let's jump right into business. Let's not waste any time. If we look at 4.2, all right, we answered 4.1.1, 4.1.2, and 4.1.3 yesterday, so we're not going to repeat those questions there. All right, we're going to look now at 4.2. And in that question, we can see it says, refer to the diagram below and answer the questions that follow. So what we have here is a Cartesian plane. We have a standard angle, all right, which is defined by theta all the way to the fourth quadrant. Okay, and yeah, so there's obviously a few things that we can actually then get from the diagram itself. Okay, all right, from the get-go we have someone who is requesting, so let's allow the person to come through. So that's the Cartesian plane. We have a terminal arm, we have 15. Okay, this distance here is 15. We have P, which is x and -9, and then we have that angle, as I said. And the question is saying 4.2.1, determine the value of who? Of x. Now x is x. So basically, how do we then go about finding the value of x? We should know exactly what we need to do to find the value of x, no doubt. Okay, as you guys think, let me just take a moment here. All right, take a moment here to just share the live. Sorry guys. Okay, create a side to the x-axis and label it y. Very good, TJ. For real. Y is equal to -9. Very good. So TJ, I like your thinking. All right, so let's just reproduce this diagram there. We are told that okay, so you are saying we should produce a line, complete a right angle triangle there. We know that is 15. P is x and -9. So you said y is equal to -9. Very true. X is what we want. R we already have is 15. So TJ, for real, we said what we must do then to determine the value of x is use Pythagoras. Very good, TJ. Very good. You can show you there, TJ. You're 100% correct. So we have R, which is 15. We have y. Where did you get the y is -9? Remember, this is x and y, the point and its coordinates. So the y value is -9. X we don't know, which is what we want to find. So TJ for real said we can use Pythagoras. And what does Pythagoras state? Pythagoras says the square of the hypotenuse side. This is the hypotenuse side because it's opposite the 90-degree angle. The square of the hypotenuse side is equal to the sum of the what? Of the square of the other two sides. So r 15 squared x squared, which is what we want, y negative 9 squared. Okay, so 15 squared, guys, is what? 225, right? I believe 15 squared is 225. Is that correct? I'm sure it is. X squared plus negative 9 squared is 81. We isolate a squared. We take the 81 over 225 minus 81. So minus the 81 gives us 144. We then take the square root on both sides. Don't forget to put plus minus. So the x value is plus minus 12 because the square root of 144 is 12. Yes, this is grade 10, guys. Then, of course, our x value in this quadrant is expected to be a what? It's expected to be a positive or a negative value. Which one should it be? Therefore, x, is it a positive or a negative value? That's the question. Yes, Asenati, thank you so much. It's a positive value because in this quadrant, x is positive. So please, guys, when you are given the diagram, in this fashion, it is your responsibility to complete the right angle triangle and to find the missing coordinate. R is sorted, we have it, it's 15. X we don't have, Y we have. Okay, and then we complete the right angle triangle as you see it there. Okay, then we can write here 90 minus theta. It's very important that we define that angle here, 90 minus theta. Obviously, we know that this here would be the sort of like the reference angle, okay, which is acute. So we have 90 minus theta, and then theta. 3 angles here. Okay, so the x here is 12, x is 12. Okay, and then as I said, you can fill in the missing side. So you have 12, which is the x value, you have y, which is negative 9, you have r, which is 15, you have 90 minus theta, the missing angle here, and then you have theta here, and then you have the 90 degrees there. So 90 theta, 90 minus theta. Then if you add those 3 angles, you should get 180 degrees for your triangle there. Okay, so x value is sorted, that is 12. Yeah? Then if we go to the next one, it says calculate the value of cos theta minus sin theta without the use of a calculator. Okay, so how would we go about this one? Okay, sorry guys. Cos theta minus sine theta. Cos theta minus sine theta. So here, what is this? It's a matter of actually using the diagram. Cos of theta, we go to that diagram. And TJ Forel there says, for cos, the definition of cos, we know. Ne? So we know that's theta. Then we say adjacent over hypotenuse. So that's 12 over 15 there. Minus sine theta, we know is opposite over hypotenuse. So that's negative 9 over 50. Then we add those fractions. The denominators are already the same. So minus times a minus is a positive 9 over 15. We add the numerators. 12 plus 9 over 15. Then we can simplify this further, right? 21 over 15. The highest common factor between 21 and 15 is going to be 3. How many times does 3 go into 21 and how many times does 3 go into 15? So the simplified answer is most preferred than the unsimplified. Yes, TJ, very good. Definitely a 97 over 5. We've got that. Wanga 7 over 5. Good. So we all got 7 over 5. Okay. Right. So these questions where we have Pythagoras type questions and we are given a diagram, we shouldn't have a problem answering those. Right? Not a problem at all. I'm just thinking, had they said, for instance, let's just say they said they want the value of cosec. Let's just write this, cosec 90 minus theta. Grade 10. Yes, it's grade 10. What would you have done if they had said they want the value of cosec 90 minus theta? So one said they wanted the value of x, which we got. 2, they wanted the value of cos theta minus sine theta, which we used the diagram and we got. Now in this question, number 3, they want the value of cosec 90 minus theta. What would we do in this situation or scenario? Cosec 90 minus theta. I repeat, cosec 90 minus theta. How would we get the value of cosec 90 minus theta? We use the reciprocal of which angle? That angle. What is the angle? Grade 10s. Boys or cold, you want grade 8. When are you writing? Boys or cold, when are you writing grade 8? Cosec 90 minus theta, guys. Cosec is hypotenuse over opposite. Very true. Hypotenuse over opposite of sine, and 90 minus theta is an angle in the triangle. Very true. Okay, so guys, remember when I said that this triangle, it's important to fill in all 3 of your angles. Okay, so 90 minus theta is the third angle. You see, we have 90, we have that angle there. That 90 minus theta is the third angle. So we come here, we come directly here, and we come here, and we know that the reciprocal trig ratio cosec can be expressed in terms of sine. But more specifically, if sine is opposite over hypotenuse, then cosec is hypotenuse over opposite. Hypotenuse over opposite. That's cosec 90. 90 minus theta is this angle here, not that one now, that angle there. So what do we say? We say cosec 90 minus theta is hypotenuse, which is 15, over opposite, which is 12. So our answer is 15 over 12. Okay, guys, let's directly use the definition. Okay, yeah, the angle we are referring to is 90 minus theta. Where is 90 minus theta? There. Okay, remember, guys, that initially in the diagram, when we drew the diagram, we made it a point that we fill in all the angles for the given triangle, including this one, this 90 minus theta. Always advise the learners to fill in all the angles and then find all the sides of the triangle, so that when you have all the angles and all the sides, you can then actually evaluate any given expression they may give you, any given trig expression. Okay, then it shouldn't be difficult at all. Thank you, Junior, for the heart me. Thank you, Junior. Ondando yakwa R, what's that? Yakwa R. What's the yakwa R for? Okay, a bit lost there. Okay, let's come to 4.3. Okay, if 15 cos theta is equal to minus 12 and theta is an element of 180 to 360, calculate without the use of a calculator sine theta. Okay, calculate without the use of a calculator sine theta. And then the next question, tan squared theta. Okay, where do we start with these questions? Because these questions are also important, and we just need to make sure that we are good with them too. Okay, so I see TJ for real saying cos theta is equal to negative 12 over 15. So already TJ in the comment section is saying isolate the trig ratio. Isolate the trig ratio. Cos theta is equal to negative 12 over 15. How did TJ get negative 12 over 15? Divided both sides by the coefficient of cos, which is 15. So it gets cos theta is equal to negative 12 over 15. What next? So first, very true, isolate the trig ratio. That's step number one. Step number one, lucky step number one, isolate the trig ratio. TJ for real, step number two, determine the quadrant. How do we determine the quadrant? Cos theta is equal to negative 12 over 15. That means cos is what, guys? Positive or negative? If cos theta is equal to negative 12 over 15, what does that mean? Is cos positive or negative? And how do we distinguish whether it's positive or negative? What do we look at? Okay, TJ for real says negative, CVS says negative. TJ for real is saying it's not the first quadrant. Okay, so remember, according to all students, take care of themselves. All right, we know that if we're saying cos is negative, why are we saying it's negative? It's based on the sign of the ratio, 12 over 15. Okay, so cos is negative. We know that cos is negative where? Cos is negative in the second and the third quadrant. We tick those quadrants. Okay, yeah, so that's one thing that we get from the trig ratio, having isolated the trig ratio. The second thing we get is the definition of cos, which is obviously going to be negative 12 over 15. So when we get to the place of sketching the diagram, we know at least that the adjacent side, okay, x is going to be negative 12. The hypotenuse side, which is r, is going to be 15. It's like x over r, if that makes any sense. Okay, then we leave that, we go and look at our interval. So the interval together with the sign of the trig ratio help us with determining the quadrant. So what does this mean? 180 to 360. Guys, what quadrants are we talking about when we say 180 to 360? Remember, this is a square bracket, meaning theta is an element. Theta is between 180 and 360. This is what this is saying. So 180 and 360 are in which quadrants, guys? What quadrants are we talking about here, grade 10s? TJ is saying 3 and 4. All right, but TJ has a question mark. Asenat says 3 and 4, no question mark. Sivyo says 3 and 4, no question mark. Yeah, 3 and 4 as well, no question mark. KG says 3 and 4, no question mark as well. Spogazi says 3 and 4. Tolilani says 3 and 4. It can't be the fourth, so it's the third. Okay, so if we come to 3 and 4, we come and tick additional to the ticking that happened with the cos being negative. When we said cos is negative, we said second and third. Now we check with the interval 180. Theta is an element 180 to 360. We tick for that as well. Which quadrants? Quadrant 3 and 4. Then we decide on the quadrant overlap. The overlap is happening in the third quad. So now we can go and sketch freely terminal arm here. Okay. Then we just say theta, we say 90 minus theta, very important. Then x, we don't know. No, x is negative 12, sorry. R is 15. Y we don't have. No? Y we don't have. We are going to have to find. So that's 90 minus theta. Okay. And then obviously that's the standard angle, and then that's the acute angle theta. So we go ahead now. We can evaluate before evaluating Pythagoras. So the third step. So we determine the quadrant. 3, we draw the diagram. Okay. Pythagoras is the next step. Pythagoras to find missing side, if you want to call it that. So y, so you can say r squared is equal to x squared plus y squared. We know that's Pythagoras. R squared 15 is equal to, yes, TJ, make sure that that diagram is sketched in there. They need to see the diagram, and they need to have the representation x is equal to y is equal to, after you get the value, you come and put in that y value. X squared negative 12 plus y squared. Okay, 15 squared, remember it's 225, 144 y squared. So we say 225, we subtract 144, we isolate the y with the squared. What's 225 minus 144? That gives us what? Is our brains working there? Very good, Asenati, thank you so much. TJ for real. Then we take the square root on both sides, put plus minus, because according to the y value here, the y value, how is it supposed to be, positive or negative in this quadrant? Yes, y is supposed to be negative. So therefore we say y is equal to negative 9, filled in. So the y value, x value, r value. R is 15, x is negative 12, y is negative 9. Now, diagram is complete, all angles and all sides. Now we can come here and find out what is the value of sine theta. Sine theta is equal to what? Sine of angle theta. Yes, opposite over hypotenuse. So if we're looking at the angle theta and we say opposite over hypotenuse, what is that giving us as a trig ratio? The value for sine theta. Okay, very good. Negative 9 over 15. Very good. Man, you guys are amazing. Okay, negative 9 over 15. Opposite over hypotenuse. Opposite, negative 9 over hypotenuse. Negative 9 over 15. Okay. I can't see hypotenuse. Okay, it's 15. I'm sorry, guys. My fault. Okay, my writing's not clear. Yeah, it's 15. Okay, remember that was 15. So you must sketch even for yourselves, guys. Don't rely heavily on just me. Yeah, sketch for yourself. Tan is going to be tan theta, the whole thing squared. So then we go to tan. What is tan? According to the definition, okay, opposite over adjacent, that's negative 9 over negative 12. But then you square it. So what do we get? Okay, negative 9 over 12, which you then have to square. Because why are we squaring it? Because that's tan squared theta. So then we have to put that value in brackets. Very good, TJ. Okay, and then we square the numerator and the denominator respectively. We get, yes, 81 over 144. Very good. Okay. Nice marks, guys. Nice marks. Nice marks. Okay. Very important. Isolating the trig ratio. This diagram tends to have a mark or two. Okay. There we have it. There we have it. Trig is a very nice topic, TJ, for real. Can say that again. Okay. No. Therefore, it's 9 over 60. No. What one? What's that? Why are you saying 9 over 16, my girl? Why are you saying 9 over 16? It's parallel here, right? It's parallel. It's not, doesn't go any further. It's parallel. It's parallel here, bro. Thank you, Junior, for the TikTok. Thank you guys for the gifts. Thank you. See, Mr. Senior is putting out some gifts today. Thank you, Mr. Senior. Much appreciated, brother. Much appreciated, brother. Thank you so much. Okay. That is that problem done and finished. Okay, that is that problem done and finished. That is that problem done and finished. Okay, yesterday we actually stopped here. Now we need to actually do this one here. Sine of 90, cos 45 over sine 60 times tan 45. Leave your answer to simplest set form, they say. So always take note of the instruction given in a particular question. Without using a calculator, simplify that. Without using a calculator, simplify that. Okay. So let me give you let's give you 2 minutes to do this one on your own. Okay. Yeah. So TJ, for real, I hear you, right? But you guys need to know the other important special angles. And by that, you can just use your calculator for them. Okay, 0, 90, 180. Okay, all of these are also special in that if you punch them into the calculator for sine, cos, and tan, you are most likely going to get either -1, 0, or 1. So yeah, just be mindful. Okay, so between the 0 and 360 interval, yeah, you know these, and using your calculator to punch in for 0, 90, 180, 360, and 270 is allowed. It's fine, because you just need to know the actual values, which can either be, like I said, -1, 0, or 1. Okay. Then for you, as far as the triangles are concerned, you just know the 60 and 30. So the triangles that are special angle triangles are only there for one, the okay, 30, 60. Then of course 45, 45. Okay, so these are the two triangles you need to know. You need to know these two triangles, because when it comes to substituting into a simplification question, you need to be rewriting the values as per the special angle triangle. So we have the 30-60 triangle, which is 2, 1, √3. And then you have the 45-45 degree angle triangle, which is √2, 1, and 1. So if we start there, sine of 90, that is straight calculator, cos 45 over sine 60 times tan 45. So sin 90 is 1, no doubt. It's from the calculator. Cos 45, you use your trig ratio here with the special angle triangle. So cos 45 is 45 degrees. Cos the adjacent side over the hypotenuse side. So that's 1 over √2 over, we say sine 60. Sine of 60, we go to 60 degree. And we look at what the definition of sine is. So what will be the value of sine 60, guys? Okay, so cos sine 90 is 1. Cos 45, 1 √2. Then sine 60, sine is opposite over hypotenuse. Very good, guys. √3 over 2. Right? Tan 45, that's 1. Because it's 1 over 1, which is 1. Then numerator 1 times 1 √2, 1 √2 over √3 over 2 times 1, that's √3 over 2. Then what do? You play the divide, multiply. Final answer. 1 times 2 is 2. Is then cos 45, 2 over 2. Cos 45. No. √2 over 2. Remember, TJ, it is that, but we do not use the calculator for in grade 10 for the 45, 45, and the 30-60 degree angle triangle. Neither do we utilize the rationalized fraction or the rationalized denominator fraction, which is basically the √2 over 2. We use the given, for the given triangle, the 45 degree and 90 degree angle triangle, we use that for our definitions. So cos 45 is defined, okay? Cos 45 is defined as adjacent over hypotenuse. So that's hence 1 √2, okay? So that's no problem. So it's okay sometimes. Overthinking is not all too terrible. It's actually a beautiful trait to have. Okay, then that's why we have 1 √2. Then sine 60 is √3 over 2, and then tan 45 is 1. So when we simplify, what's 1 times 1 over root 2? 1 over root 2. Root 3 over 2 times 1? Root 3 over 2. Then we do the 1 over root 2. This line means divide. Then root 3 over 2. Root 3 over 2. Then you change, keep the first fraction. We actually apply KCF. Yeah, nearly said KFC. We don't apply KFC, guys. We apply KCF, meaning we keep the first fraction. We change the sign, and then we flip the fraction that we are looking at. Flip it. What do you mean by flip it? The numerator becomes the denominator. The denominator becomes the numerator. That's what we mean by flip. So you keep, divide becomes multiply, you change, and then you write root 3 over 2 as 2 over root 3. Then when you finally multiply, 1 times 2 is 2. Root 3 times root 3, root 2 times root 3 is the same thing as putting 2 times 3 underneath the same square root. We have 2 root 6. And this is basically leaving our answer in what? Leave your answer to simplest third form. So that was simplest indeed. Okay. So guys, please, whenever you substitute, use your right angle triangle. 1 root 2, root 3 over 2, 1 and 1. Then it's like simplify, answer. 5-mark question. And they give away those marks like freebies, man. Okay. Any questions, guys, from the floor? Hey, Lems.
Hey, what up?
What up?
I'm good.
You good. What grade are you in, Lems?
I'm in grade 10.
Grade 10.
Yeah.
Have you written already?
Yeah, I'm done.
You done? Oh, so you are chilling very hard.
Yeah.
So are we getting a distinction then? Come your report, your exams, you wrote very well.
Kind of.
Kind of.
Yeah.
So do you still feel like there's topics that you still need help and assistance with from the term 1 and the term 2 work that you've covered?
Exponents and ratios.
Exponents and
Ratios.
ratios. Exponents and ratios. Ratios are done in grade 9. Are you sure you're not in grade 9, Lems?
No, I used to not listen in class.
Yeah, but what I'm saying is currently, did you write a test? In your test, did ratios come out?
No.
Oh, okay. So you're saying that you still have problems or issues with exponents, and did you guys do functions?
We stopped.
You stopped what?
Doing functions.
You stopped.
Yeah.
So did you write 2 papers, paper 1 and paper 2?
Yeah.
All right. So what was the paper 2 on? What topics were in paper 2?
It was... Wait, let me remember. Wait, I'll tell you when I remember.
Yeah, I have a feeling there that this boy is actually not in grade 10 in actual fact. That's, yeah. Olelani, will there be trigonometric graphs? Well, you should be telling me that. Did you guys do trig graphs? And was that something you were told would be there in paper too? You know, yeah. Yeah, it is concerning, TJ. You might as well say that again. Very, very concerning. Specifically, how's it? Anita Mswana, how's it? Specifically. Specifically.
Mnandi lithi.
Mnandi mfethu.
Yeah, angazi noma yimi
What?
ngifika late la ku live yakho because manje seems like sekustophiwe.
Say that again.
Ngithi angazi ukuthi I'm late yini because ngibona ngathi awusaqhubeki umile la.
No, look, I'm coming here. I'm checking on you guys. You see. Yeah, I'm checking on you guys.
Yeah,
So
because
specifically, cause fair to.
you can continue. I'm listening.
What grade are you in, specifically?
I'm doing grade 12, my man, and I'm writing on Thursday, man.
You're doing grade
My paper 2.
Oh, you're doing grade
Yeah,
12.
I'm writing on.
All right. No, this is a grade 10 live, specifically. This is for grade 10.
It's topic trigo le.
Yeah, it's trig and analytical for grade 10.
Oh yeah, I'm confused. But okay, when was the whole studying Betty Life, yeah, matric.
All right. Is it Khotazo?
Say,
How is it?
I'm good on you, say.
No, I'm very good. So are you in grade 10?
Yes.
Okay. Yeah, I was beginning to think, I strongly believe that the first person that I was talking to was in grade 9, but they were trying very hard to hide the fact that they're in grade 9. Because anyone who mentions ratio is done in grade 8 and 9. So I was like, yeah, most deaf. Okay, so the problems we've done so far, good, sorted, like special angles, we are good, Pythagoras type questions, drawing a right angle triangle in a quadrant, you're good.
Yeah.
Okay, you've written
No. I don't want to
so
paper
you've not
one.
written paper 2.
Yes. I don't want to Thursday.
Oh, okay. Paper 1?
Paper one wait.
Okay. All right. Okay, then Khotaz, I want you to actually help me here. Yeah. So let's put you guys. I think we've been having a lot of fun, but let's come here. Come on over here with me. Can you see on your screen?
It's
No, I'm just asking. You can see on your screen, right?
yeah.
Yeah. Let's read the question 4. Are you ready?
Yeah.
Yeah, you can go ahead, my guy. Me, I will just follow along.
Out loud.
Yeah, please. The audience is waiting.
During the opening of the ancient Olympic Games, the Olympic flame was lit by athlete A that shoots an arrow through a ring R into a bowl of oil, which is O.
Okay, so let's just check this thing. Here is athlete A. Shooting, ne? This is during the opening of the ancient Olympic Games. The Olympic flame was lit by an athlete A. So here is athlete A. He's standing there shooting. Bah! Ring R is there. That shoots an arrow through a ring R. There is athlete A shooting. Bah! Here's ring R. Ne? Yeah, and apparently they say you shoot through the ring ne? Into a bowl where here. So you can imagine this guy shoots bah, through that ring into that into a bowl of oil here. Ne? So we are together so far ne? With that first paragraph.
Yeah.
Okay, let's continue.
The bowl of oil is mounted on a pole P. The angle of depression from the bowl O to the athlete A is 18 degrees.
Okay, let's stop right there and just analyze this. So they're saying the bowl of oil is mounted on pole P. So this is pole P, ne? The
Yeah.
bowl of oil is mounted, meaning it's put on top of pole. There's a pole here, and then the bowl is mounted on there. Ne? The bowl of oil is mounted on a pole P. Then they say the angle of what? Of depression. From where? From the bowl O to the athlete A is 18 degrees. So let's check this thing. There is the bowl. Here is the angle. That is 18 degrees. And they call that the angle of depression from the bowl to the athlete. Yeah. To the athlete A. Now, the word depression, when you are depressed, have you felt depressed?
Yes.
Yeah, when you're feeling depressed, do you feel happy?
No.
You feel how?
Down.
Yeah. So we're looking from the top down to the athlete at point A. Then there's an angle formed with the horizontal and the line of sight. Are you with me, guy?
Yeah.
An angle formed with the horizontal and the line of sight if we are standing there at the top. That's what we call angle of depression. Hence, when they used or when they described here, they said the angle of depression from the bowl O, because we are at the top looking down. When you are depressed, you feel down in the dumps. So the angle of depression from the bowl O to the athlete A is 18 degrees. So it is that angle. Ne? Okay. Are we good?
Yeah.
We can proceed to the next paragraph, ne?
Yes.
Okay.
The ring
Go
R
ahead,
is
my guy.
The ring R is positioned at a point G above ground so that the top of the ring is 7.5 meters higher than the bowl of oil's height, which is 8 inch.
Okay. So the ring R, there is the ring R, is positioned at a point G above the ground. Ne?
Yeah.
Yeah. So that the top of the ring, so the top of the ring is there at the pinnacle of the ring. At the top, we are talking there. If they said at the bottom of the ring, we would be talking about here. But they are saying the top of the ring, so they mean there, at the pinnacle of the ring. So they are saying so that the top of the ring is 7.5 meters higher than the bowl of oil's height. Okay. So there's the bowl of oil. The distance from the bowl of oil to the top of the ring
It's
is the
7.5.
7.5 meters that you see there. So you can see that they've measured it from the horizontal of the bowl of oil to the top of the ring. Then the 7.5 is actually inserted there to indicate that. Are we good?
Yeah.
All right. Then let's read the concluding statement so that we can sort of like have a fuller picture then of the diagram.
The distance from the athlete A to the ring is 80 meters with the angle of elevation of 30 degrees. From the athlete A to the top of the ring R.
Okay, so now they are talking about what? The distance from the athlete A to the ring. The athlete A to the ring, the distance is what?
80 meters.
80 meters, and it's labeled, right?
Yeah.
So what's nice about so this is the thing, when you have a story, sort of like a representation of a particular diagram, what the important thing is to analyze what is in the scenario, of course, reading line by line, and then looking at whether the information represented in your words is actually represented in the diagram, because we need to obviously see the relationship between what is written there and what is in the diagram. If there are things that are missing from the diagram that we see here, we need to include them so that we can have a more fuller understanding of the picture. It is the picture that's going to assist us ultimately in being able to answer questions 4.1 and 4.2 when they do come. So yeah, analyzing, reading, comprehension, English. Analyzing, so reading first for the purpose of analyzing, English, because unfortunately this is not Tswana, this is not Sotho, this is not Pedi, it's not Zulu, it's not Xhosa, it's English. So then we need to read with understanding, and then we need to convey whatever meaning is here onto the diagram so that we can use the diagram to answer questions. Okay, and hopefully we can understand. Yeah, so the distance from the athlete A to the ring, we can see that one. That's clear, ne? This first part.
Yeah.
With the angle of elevation. So earlier on they spoke about angle of depression, and hopefully I'm hoping that from the description of the angle of depression, from the statement to what we see in the diagram, brings a clear meaning of what angle of depression is.
Yeah, which is the opposite of the angle of depression.
Yes, exactly. So now we are talking about the angle of elevation. Okay, the angle of elevation of 30 degrees, they're saying, from the athlete A to the top of the ring. So here is the athlete looking at the top of the ring there. The angle formed by the horizontal and the line of sight. Ne? Yeah, from the athlete. So the athlete is looking where? Up. So we call this the angle of elevation, this angle, because from the bottom looking up, there's an angle formed by the horizontal and the line of sight. So is that clear, my man? The horizontal and the line of sight forms an angle which we refer to here as the angle of elevation, right? So to elevate,
it's to go up.
Justin, yeah, exactly. You see, it's to, when you elevate anything, it's like you are lifting it up, you are bringing it up. If you talk about marks being elevated, moving from one level to another, hopefully,
Yeah.
So I hope then that also brings sort of like a clarity about the concept of angle of elevation. angle of elevation, the angle formed by the horizontal and the line of sight. We are from the bottom looking up. So hence we call that the angle of elevation. Okay. Then it says with the angle of elevation of 30 degrees from the athlete A to the top of the ring. Oh my soul, this guy always. KVM, the might as well. KVM just always. It's like snack attack. Thank you so much, KB. Thank you, appreciate it. So I hope that's clear, Khotatso,
Yeah.
Yeah. So I remember when I showed you this diagram, what was your first reaction when I showed you this question 4?
I was scared.
Exactly, eh? But if you think about it now that we've actually like taken each line and each statement, each paragraph, and we've unpacked it and we've attached meaning to it, how then does that now make you feel? At least now, since we've defined everything and we've sort of like unpacked everything, do you still feel the same sort of like fear or sort of state of like not knowing or being despondent that you felt at the beginning?
No.
No, yeah. And I'm sure now you can kind of sense that this is doable, right?
Yeah, but I struggle with Euclidean geometry.
Okay, no, I hear you. But can I tell you something, Khotat? The only reason why you probably struggle with Euclidean geometry is because it's kind of like the same reason why you were shocked at the beginning before we unpacked this thing.
No.
Sorry?
Since the start of the year.
So since the start of the year you've struggled with Euclidean?
Yeah. And then the rest.
Oh, okay. How was Euclidean geometry in grade 9, Khotat?
It was average.
It was average.
Yeah.
Okay. So does that mean in your paper 2, Euclidean geometry will be featuring as well?
Yeah.
And when did you say you were writing?
Thursday.
Okay. So then let me promise you this then, Khotat. Tomorrow I'll dedicate my live session to Euclidean geometry. Yeah. Unfortunately, I won't be doing that today, but I'll dedicate the live lesson for tomorrow to Euclidean geometry. Yeah. Or maybe, yeah, because I suppose I also need to get a sense as to what is everybody else going to be writing on with paper in their paper too. It's just that I know the group of learners that I've been helping, most of them have been saying that they're doing trig and analytical, but yeah, we'll look at Euclidean as well, no problem. Okay. All right, so that's fine. So let's look at the question now. Determine RG, the height from the ground to the top of the ring. Determine RG, the height from the ground to the top of the ring. So we see where the ground is, Khotat.
Yes.
And we can see what they are talking about, the RG that they want. Okay, are we both sort of like referring to this place here?
Yeah.
Okay. So how are we going to determine the height from the ground to the top of the ring for RG? What are your thoughts?
Maybe we have to solve it. We have to start by stating that we are using triangle RGA.
Okay. Oh wow. Very good. Okay. So in triangle RGA. Thank you so much for saying that. So we need to first identify the triangle where we are working. I really like that. I really like that you said that. Okay. Because I mean, there's so many things happening here. This diagram is very busy. But if we zoom in and focus on a specific aspect of the diagram, then it will assist us. This is for 2 marks, by the way. Okay, so they want us to determine RG. Okay, then after that,
Then wait, is working the angle of athlete A? Can we call it theta?
which angle?
Angle A, 30 degrees.
Angle A here.
Yeah,
You want us to call it what?
theta.
Theta.
Yeah.
Why do you want us to call it theta?
I think it will help us solve the and
Okay, so what do we want to solve for in triangle RGA? What do we want?
we want the height of RG.
Okay, then in the triangle, what do we have?
We have the hypotenuse and the angle.
So we want RG, we have the hypotenuse, you said, which is
Yes.
what? What is the
80
hypotenuse?
80
It is
meters.
80 meters. Okay. So that's RA, ne? Okay, what
Yes.
else do we have?
And we also have angle A.
Angle A. Thank you so much. Angle A we have. What is angle A?
Theta. Or 30 degrees.
It is what? It is?
30 degrees.
Yeah, 30 degrees because we have the actual angle. Okay. Yeah. So we don't need theta. We have the actual angle. Also remember, we have we can use the arms to refer to the angle. We can say it's angle RAG, or we can say it's angle GAR, or we can say it's angle A, as you have said. Okay.
Yeah.
Now, knowing all of that, in that triangle, to find RG, what trig ratio can we use? Because we can use a trig ratio, right?
Yeah.
Yeah. So what is the trig ratio we can use to find RG?
Sin.
Okay. We can use sine, definitely. All right. Why can we use sine? Because the side that we are looking for is called the what in relation to this angle? It's called the opposite. And then RA is called the what in relation to this angle?
Hypotenuse.
Yeah, so then it means that if we want the opposite and we have the hypotenuse and we are working with an actual specific angle, which is 30 degrees, then sine of this angle can be used. So then we are going to say, as TJ for real said, sine of 30 degrees. We can be very specific. For triangle RGA, sine of 30 degrees is equal to RG over 80 meters. Okay?
Yeah.
Yeah. All right. Then after that, we want to solve for RG, which is in the numerator. So what do?
You have to multiply on both sides.
We have to multiply by 80 meters both sides. Thank you so much for saying that. We multiply by 80 meters both sides in the numerator. Specifically, we multiply by 80 in the numerator because this 80 is in the denominator.
Yeah.
Okay, that cancels. So RG is equal to 80 times sine 30. Grab your calculator, punch it in. You should be able to get the length of RG. Okay. And my people that have their books. It is?
40.
40, right?
Yeah.
Okay, beautiful. That makes life very easy. Okay. Nice to see. 40 what? The unit that we have? Yeah, this was given in meters, so obviously that means it's 40 meters. Yeah, please, if there's a unit, SI unit, we ensure that our answer reflects the given SI unit, all right? But if there wasn't any SI unit, then we'd go ahead and actually say 40 units, all right? as a representation of the length of the side. Once we have that, you go ahead and you update your diagram, because that means you have 40 meters, which is the entire length of RG. Okay. Okay, are we good?
Yes.
Okay, are we sure we're good? Like that was easy, right?
Yes.
Yeah, very nice, very sweet, very nice. And maybe some people will be wondering, but sir, how did you know that this is a right angle triangle? Remember, guys, they said that the ring is positioned at a point above the ground, so that the top of the ring is 7.5 meters high than the ball of the oar's height, right? So the thing is, we kind of understand that that is a perpendicular height, all right, to the ground. So hence we basically then know that that is 90 degrees. It's perpendicular to the ground. Okay, we can definitely deduce that. We don't assume it, but we deduce it from the fact that this is a perpendicular height to the ground. Okay, let's go to 4.0.
Determine the distance x that the athlete is standing from across the base of the pole P. Round your answer off to the nearest whole number.
Okay, so you can see they have that thing, the distance x. So they want the distance that the athlete is standing from the base of the pole, So they want this entire distance.
Yeah.
Fun in the sun, isn't it?
Yes.
Yeah. Now this is what I call nice problems. They in life, there's what we call nice life problems. These are nice life problems. I'm sure my gifter there, hey, I just have to thank this man. KB, thank you so much. Just want to take this moment before we proceed to this question. Thank you so much for the gifts, sir. I really appreciate it. Thank you for the paper crane. Thank you for the hand heart there. And thank you for the roses as well. 30 of them, including that one as well. Thank you so much. Really, absolutely appreciate you too much. I thank you, sir. Thank you. Okay, so yeah, that is me trying to delay so that I can give you a chance to really think about how can we go about this. I see there's some people who are commenting in the comment section. But what are your thoughts?
Wait.
Yeah, don't worry, I'll give you time. I'll definitely give you time to think. We're not too much in a hurry.
Yeah, we have to use cos because we have to calculate the adjacent, which is x, and we have the hypotenuse, which is 40 meters.
You have the hypotenuse, which is 40 meters.
And then we have to calculate x, which is the adjacent.
Now, where is the hypotenuse?
Isn't it OA?
OA. Do we have that? Do we have that length, OA? That's my question. Do we have OA?
Oh, no.
Yeah, remember this 40 that I put in was a representation of the height.
Of the height.
RG. Ne?
Yeah.
Yeah. So let's not forget that one.
So then can you help me with this one then, sir?
Okay, I actually would love to, but I'd also love to actually see what other people have to say. So anyone who wants to request can come through, and we can have people throw around their thoughts, because I'm not gonna lie to you, it would be very easy for me to just sort of like say, hey guys, we do this, but I'd love to see what you guys think. Hence I'm allowing some time for you guys to think, right? TJ for real in the comment section is saying something to do with that 18 degrees. What can we do with the 18 degrees? That could be helpful. If people are saying something to do with 18, what can we do with the 18 degrees? Is there anything that can be done with the 18? Is it going to help us with anything?
So isn't it the alternate angles?
Okay, alternate angles. Okay,
Hmm.
I hear you there. So what angle is that?
Angle AOR. Should I say R?
A
O
O
R.
AOR.
The horizontal line going from,
Oh, this horizontal. Okay, I
yeah.
see I see that 18 degrees. But I see that 18 degrees, but what are you going to do with it?
Isn't it alternating with angle OAP?
Okay, very good. So basically you guys are saying that's 18 degrees.
Yes.
Okay, yeah. So angle OAP is equal to 18 degrees. And yes, that's alternate angles. All right. We can just sort of like write parallel lines. Yeah. So that's true. That's 18. Okay. But then I ask the question again. So what is that going to then help you with? You have this 18, okay, which is for this triangle. Okay.
Yeah. So then now we can calculate the distance of x using cos.
We can calculate the distance of x using cos. Cos for
Cos
which triangle?
Cos 18 for triangle OPA.
OPA. But what do we have in this triangle? We have this angle 18. What else?
We also have,
remember, the 40 guys represents this height. Let's not forget that. Eh?
yeah.
Yeah, 40 represents this height. TJ kills me in the comment section because every single time you speak or there's something said, he's I don't know if he's having a certain realization. Just that a pity TJ does not have guest options there to actually come on and speak, so that's unfortunate. Okay, here's something I can sort of like give you as a clue. 18 plus 90 is going to give us the other angles, just so we know all angles inside the triangles, I think. Okay, Asenat is saying 18. Okay, I see that 18 plus that 90. I mean, we can always get that angle. We can always get that angle. You see, with the 30, with the 90, we can get that angle too. Okay, I get that. But how is that going to help us at the end? Okay, so here's another little bit of a clue here. Okay, if you get this 18 degrees, my question is, can you get the height of PO? Is there a way that you can get the height of PO? Because you have the 18, you have the height, you can definitely get this length. Because it's apparent that we don't have this, we can't get this, but we can definitely get that because we will have the 18 and we'll have that. So is there a way of us getting the length OP? I don't want to tell you guys. I want to sort of like lead you into it. So can you get OP, Hotat?
Yeah.
Huh? What do you know about RG?
It's 40 meters.
And what do you know about from here to the top of the ring?
It's 7.5 meters.
It's 7.5. So if you want to get this length here, from here to there will be the same distance from here to there, won't it be?
Oh yeah. So
Yeah.
then we have to minus 40 from 7.
Exactly. Look at Asanat in the comment section already also figured it out. Yes, because full height of ring, okay, the full height of the ring to the top of the ring to the ground is 40. We got that, didn't we, earlier on?
Yeah.
Yeah. Then if we subtract 7,5, it means that we have the distance from this point, which is the same distance from the point of where the oil is, okay, to the bottom of this pole.
Yeah.
So that means we would then have the height, all right, for triangle OPA. Make sense?
Yeah.
Okay. So it needed a little bit of thinking.
Yeah.
All right. So there's this connection between the height of RG, which we got, which is 40 meters. We subtract the 7,5, which will give us the distance from here to the ground, which is the same distance as from the oil to the bottom of the pole. Same distance.
Yes.
Yeah. So if we come here, then we first got angle OAP is equal to 18 degrees. Alternate angles. Lines are parallel, of course, you know. Then now we could then go on and say OP is equal to RG minus 7,5 meters, because unfortunately we don't have a specific, like, yeah, if you call it what you want there. So that means 40 minus 7,5, and you guys get what? What's 40 meters?
It's 32,5.
It's 32,5. Okay. Then once we get that, we go on and fill it in the diagram. 32,5 meters. Okay. Then we relook at the diagram. In triangle who?
Triangle OPA.
Exactly, OPA. Then what can you do there? Sorry, let me just put in the 18 degrees as well, because we had obviously found that there.
And we need to use 10. And 10, 18 is equals to opposite.
10, 18 degrees is equal to, yes?
32,5 over
32,5
over x.
Exactly, over the entire x, which is what we want.
Yes.
Okay, so now this time round, unlike the previous question, remember the previous question, our unknown was in the numerator. And what we did is we multiplied by the denominator, both left and right. This time round, our unknown is in the denominator. So what do we do?
We have to multiply x on both sides still.
Okay, multiply by x on both sides.
And then they cancel each other on the right hand side.
Okay. Then we get x tan 18 degrees is equal to 32,5 meters.
And then we divide by 10, 18 degrees on both sides.
Very true. Divide by 10, 18. Now, I know some people in the comment section are just saying it would have just been easy to swap. Very good. Interchange. Then the shortest method would have been to, and this is the shortcut, you interchange between the tan 18 and the x. X replaces a tan 18, tan 18 replaces x. It's called interchange, right? So if the unknown is in the denominator, you interchange. If the unknown is in the numerator, you cross multiply. So here, cross multiply, here, interchange. Okay, that's like the shortcut.
Yeah,
Yeah.
and x is equals to 100 after rounding off.
Is it 32.5 over tan 18?
100.
Is it?
100
Okay, oh
meters.
wow. Okay, that's beautiful. Okay, that's like Usain Bolt, right?
Yeah.
Yeah, he's running the 100 meters there. Okay, from the pole to the athlete. Just it's interesting because we're talking about Olympic Games here. So 100 meters is the distance. Okay, because the question says round off your answer off to the what? The nearest
Whole
whole
number.
number. So 100 meters is spot on, buddy. Okay, let me clap for you there. You did very well. Okay. No questions, Mr. K?
No questions.
Okay. Yeah, that was smoothly done, eh?
Yeah.
Yeah. So must not be moved by questions that seem to be imposing level of difficulty, but are actually very nice, smooth, and sweet. Yeah. All right. That was a nice question. All right. Okay, so trigonometry, is there anything that kind of like tends to be a bit of a problem for you, or anything in analytical currently, anything at all? Or we're kind of cool with those topics. It's just that you are seriously just wanting that Euclidean, that's all.
Yes.
Okay. I think let's do one last one.
Also, we can do the one for identifying the quadrants because I learned that yesterday during the live.
Repeat the one with doing the quadrants.
Identifying the quadrant, the cast method, or yeah.
Do you mean with the sketching of the diagram, or do you mean just identifying the quadrants using the trig ratio?
Any.
Or anything that has to do with that, you mean?
Yeah.
Okay, let's just see if I can't. Okay, let's go to specifically here. Nothing really beats the textbook when it comes to things like that. So let me just, because obviously I've been using question papers, but let's see. Okay, here we are. All right, let's come right here. Okay, let's come right down here. Here's a question here. Let's come down, strike smack bang here. Letter F. Okay. It says if 13 sine alpha minus 5 is equal to 0 and cos alpha is less than 0, determine without the use of a calculator and with the aid of a diagram the value of cos alpha minus tan alpha and 169 cos squared alpha minus sine squared alpha in brackets. Okay, so I hope you kind of caught a glimpse though of like if you remember when we did the one question, it was kind of like a procedure that I said we can follow, where we need to kind of step one, isolate the given trig ratio. So if 13 sine alpha minus 5 is equal to 0, sine alpha minus 5 is equal to 0. Isolating sine, what do we do?
We have to transpose -5.
Very good. We transpose the -5. It becomes
It becomes 13 sin alpha is equals to 5. Then we
okay. Then after that,
divide by 13 on both sides.
okay, divide by 13 both sides, which gives us what?
Sin alpha is equals to 5 divided
Sine
by
alpha
13.
is equal to 5 over
13.
okay. So that is like step 1. That's a good accomplishment. Okay. Then the next thing is we need to do what? Determine the quadrant, which comprises a few steps there. Okay. Yeah. So isolate the trig ratio. Now we need to determine the quadrant. And to do that, we say sine alpha is equal to 5 over 13. Is this positive or negative? 5 over 13?
Positive.
Yeah, so that means sine is positive. Then you ask yourself, where is sine positive?
On the first quadrant and on the third one, I think. Yeah.
First and
On the wait, can you do yeah, on the first one and the second one.
Yeah, okay. First and second, guys, please, eh? Yeah, first quadrant, second quadrant, third, fourth. This is all students take chemistry, all students take chemistry.
Yeah.
Yeah, so first and second, that's where sine is positive. Okay, that's the first thing we extract from sine being isolated. The second thing we extract is the definition of sine as per 5 and 13. That is opposite over hypotenuse, which translates into y over r in the Cartesian plane, which is that 5 over 13. So at the top means y is 5. At the bottom, r is 13. That's when we draw the diagram. So that helps us out a lot. Then we go and look at our second piece of information. So we are done with this here for now. Then we ask here, and cos alpha is less than 0. What does this mean? Cos alpha less than 0.
Means cos is negative.
Exactly. So cos alpha less than 0 means cos is negative. Then the question you ask yourself, where is cos negative? We are going to come back to this quadrant and we are going to tick where it's negative. Where is cos negative?
On the second and the third one.
Okay, once again, second, okay, and then third. Then we ask ourselves, where is the overlap?
On the second quadrant.
Exactly. And then that's where we sketch our diagram, second quadrant. So that means we draw a terminal arm in that quadrant. Okay, we complete a right angle triangle. Then we know MOS. We have the standard angle. We have our reference angle there. Okay, which is that representation of that theta. And then we know MOS that we are going to use 5 over 13 to then sort of like label the sides. So I usually say mark the 90, then you make sure that's 90 minus alpha, the angle there at the top, 90 minus alpha, because we are dealing with alpha, then it's alpha there. Then here, 5 over 13, opposite over hypotenuse. That's 5 over, so that's y is equal to 5, r is equal to 13. Then we have a missing side. So what do we do to find the missing side?
You have to use the Pythagoras theorem.
So that is our next step. R squared is equal to x squared plus y squared. We know that's Mr. Python. R 13, we square it. X, we are looking for him. Y, we have him. Okay, what's 13 squared, my guy?
169.
Amen. X squared plus what's 5 squared?
25.
Awesome. We transpose the 25. We don't forget about the change of the signs. We get 144 is equal to x squared. What is the square root of x squared and the square root of 144? Don't forget, guys, we
I think
put
it's
plus minus here because it can either be a positive or negative. The minute you take the square root, you must put plus minus. It's like it's like something that you need to always remember. For your even exponent, you take the square root, you put plus minus.
yeah, and
Final
then it's
answer.
x is equal to 12.
So therefore, x, based on where the diagram is, the x values are how in this quadrant?
The x values are negative.
Exactly. So therefore, we are going to say x is equal to negative 12
Negative.
only. We embrace the x is equal to negative 12, not the x is equal to positive 12. We then label and we complete our right angle triangle like that. All angles, we have them in that diagram, all sides, which is what we need. Okay. Now we can use the diagram. Answer which questions? Those two. What is cos alpha minus tan alpha? Cos alpha minus tan alpha. Cos alpha, go to the diagram. You read what is cos alpha.
It's adjacent over hypotenuse.
Okay, talk to me. So what's the actual fraction?
Adjacent is 13 over no, it's negative 12 over 13 minus.
Thank you. Thank you. Negative 12 over 13. Thank you for actually picking up on your own error. Okay, then tan alpha.
10 is negative 12 over 5.
Okay, I'm gonna allow you to check one more time. What is 10?
10 is opposite over adjacent, right?
Okay,
Oh, it's
yes,
5.
that's true.
Yes, it's 5 over negative 12.
Yeah, so be very careful there because you were convinced for sure that it's negative 12 over 13. So just make sure you double check whenever you are. Yeah, your definitions need to be clear. Let's not forget, my guys, beautiful SOHCAHTOA can help a lot. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. But then we also must not forget SOHCAHTOA as well for the reciprocal trig ratios. Cosec, hypotenuse over opposite. Sec, hypotenuse over adjacent. Cot, adjacent over opposite. So let's not forget these guys. They help reciprocals, then basic trig ratios. Okay. Ne?
Yeah.
Yeah. Okay, then we just do the maths, Kengoku. That's all. Negative 12 over 13. Negative times the negative is positive 5 over 12. You can actually put all of this in your calculator actually and get the answer, and you won't get penalized because the idea or the notion behind without the use of a calculator does not necessarily mean you don't use a calculator at all. It just means they want to see your steps and they want to see a drawn diagram which is going to represent the respective sides, and then you can replace those ratios for those trig ratios so that you can simplify and get an answer.
Oh.
So what do you get?
Wait, let me see.
Negative 12 over 13 plus 5 over 12.
Oh, plus. Oh, wait, sorry.
Yeah.
It's negative 79 over 156.
Thank you. Job complete. Job done.
Wait, can I screenshot the...
Sure you can, my brother.
And the question?
So the question, yeah, and I guess you can probably take the others as well because, yeah, so these are other questions that you can do that are related to this F that I just did here. Well, I actually did this part, and I need to just do that part as well so that you can see it.
Yeah, it's fine.
Yeah. So yeah, man, these Pythagoras type questions, they are filled with marks. You just need to make sure that your diagram is there because, yeah, like let me just say, so isolating the trig ratio, 1 mark. Sketching the diagram, filling it in using Pythagoras, because you get a mark for the diagram, you get a mark for showing Pythagoras, getting the actual value and filling it in. So usually the diagram might have 2 marks, 1 mark for this Pythagoras. Substitution into the required trig ratios, final answer. Okay.
Yeah.
So please, hey, these are critical marks. Yeah.
Ish.
Yeah.
So can you please
You can't
excuse
lose.
me for 2 minutes?
Sorry?
Can you please excuse me for 2 minutes?
No, it's fine. You can. It's fine. You can be excused. You can be excused. You can be excused. As a naughty girl,
Yes, sir.
how are you?
I'm fine, and you, sir?
No, I'm doing swell. I'm doing swell. Yeah, today I just kept you there in the comment section. How has it been being there? Just there.
It's been fine.
It's been fine. And I'm sure the confidence is getting high. Eh?
I know, got trig. I know
Yeah.
what that marks then.
Yeah, fun and games. Eh? Like it's gonna be walk in the park. Yeah, I get.
Where are people today?
Where are people today? I don't know. I don't know.
17 lapha ke siyabhala. The 17 is here siyabhala.
Yeah. But it seems like people are chilling there, having a nice time. We are here. Pagamile
No,
is
come
like. Oh, you guys have been silently here. Senior, how's it?
I'm good, sir. What about you?
No, I'm doing well, Senior. Everything is going good. I can see.
Yeah, sir.
We are flowing very nicely now. It seems like we are seeing clearly now. The rain is going.
Sir.
Yeah, no, it must go, guys. I think, yeah, I wanted to do. There's this one question I wanted to do here. This one. These questions here. A few questions I wanted to do here. There's this person here who's standing. You see this question, a person standing at the top of a building
Yes, sir.
at U looks down at 2 of her friends standing at S and T.
Yes, sir.
And then it says the angle of depression of S from U is 47 degrees. So once again, just go there to this diagram. There's the person standing there at the top of the building,
Yes.
looking at his 2 friends at S and U and T. You can see, right?
Yes.
Yeah, and then the statement is saying a person standing at the top of a building at U looks down at 2 of her friends standing at S and T. The angle of depression of S from U is 47. Of what? Of S from U. So once again,
No, sir. Continue.
Oh, I thought you wanted to say something. So if you look at this guy who's standing there at U,
Yes.
this is his line, his base, this is the horizontal. And then his line of sight as he looks down at the person here. Right? Looking down at the person with the horizontal, an angle is formed. It's 47 degrees. They call that the angle of what? Of depression.
Pressure.
Of what? Of S from U. That's 47. Yeah. Then they say, and the angle of elevation of U from T. Of what? Of U from T is 38 degrees. So this person is looking up at the friend. His line of sight with the horizontal plane forms the angle of elevation. Okay.
Yes.
Now they're saying the distance between the top of the building and the person at S is 50 meters. The distance between the what? The top of the building and the person at S is 50. So we have 50 meters there. Now the question says calculate the height RU of the building correct to 2 decimal places. The height RU correct to 2 decimal places. Then my question is, guys, how? So something else I really like saying or asking learners when we're doing questions like this, I usually ask them, how many triangles do you see in the diagram?
Oh,
Asenat is saying 2. Junior, what are you saying?
2, sir.
2 as well. Me, I see 3, ne?
Yeah.
Because I have a bundle.
URT, URS, and UST.
Okay, you saying yo? Say that again, Khodat.
URT,
Okay, let's look at that. URT, yes, that's one triangle.
URS,
URS, that's another triangle, true.
and US.
UST.
UST. So yes. So do you see why we say 3, ne?
Yes, sir.
Yes.
Yeah. So those are just generally 3 triangles. Then I ask another question, and the second question is the one that's most important. How many right angled triangles do you have?
2.
2.
Okay, so both of you are saying 2, but not confidently, but more like 2.
2,
I'm saying 2 because most UR is going to be used Papa URS and go URT.
Okay, say that again, Asenati. You said the first
saying
triangle
two
that you
because-
see, which is right angle, is
URS.
URS. Yes, that is because you can see there's the 90-degree angle there, right angle.
And-
URS is
and
indeed a right angle
URT.
triangle, and
And URT.
URT. Very good. Right. Yeah, it's very true. So are we all sort of together with the right angle triangles that we see
Yes.
in the diagram? Okay. So then why do we ask that question? Because remember, trig ratios work only when we have right angle triangles. They will work on those triangles.
Yes, sir.
Okay. Yeah. So now they are asking us to calculate the height of what? RU. When you mentioned your right angle triangles, both of the right angle triangles that you mentioned have the height RU in them. Make sense?
Mm.
Yeah. So then, what are your thoughts? How will we calculate the height of RU of the building? We've been given US is 50 meters.
Is S and what's the other letter? I can't see.
The
Is S and T co in? Isn't common.
what about S&T?
I forgot these words, but the angles that they are equals to each other using F. Letter F. I forgot the term.
They form F shape. You mean?
Yes. Yes.
You mean corresponding?
Yes.
Which angle?
Angle T and S.
You say they are corresponding. Nope. Remember, corresponding angles are found between parallel lines.
Or
Yeah, if you say for them to be equal, there must be parallel lines. But in this case, if you're looking at S and T, this angle and that angle, they're not corresponding in that sense. But look here at the horizontal, the angle of depression. That was what? What angle is this?
47 degrees.
What is it equal to?
All in all,
Angle
Sorry?
S may indicate. Angle S.
Angle?
S.
Okay, angle S is very broad. Specifically, what is the angle?
an acute angle.
Yes, I guess it's an acute angle, but what is the angle? If you're going to refer to the angle, remember, guys, if you say angle S is very broad.
Oh, angle RSU.
Exactly, angle RSU. Yeah, because we are specifically referring to this angle. So, guys, here's the thing, all right? And this is something that people that mark they look for. If before you answer the question you say in triangle URS, okay, you mention the triangle you are working in, then you go ahead and you say angle S. Then the angle S that you write down here, I know that you are referring to the angle S that is within triangle URS. So if you state the triangle you are working in, you can say angle S, okay, loosely, because you have identified the triangle. But guys, if you go ahead and you don't state the triangle, then you are required to actually say angle USR, or you can say angle RSU with the cap on top of the letter of the angle you are referring to. I hope I'm making sense.
Yes, sir.
Are you guys really hearing me? Because
Yes, sir, I see.
Yes, sir,
yeah,
you do.
so there's a requirement that you do say angle USR if you do not stipulate the triangle where you're working. But if you do indicate the triangle where you are working, then it's fine to just write angle S loosely without actually saying angle USR. But I usually always say to learners that, please guys, always make it a point that the person who's marking does not have to be confused about what you write and what you mean. Yeah, makes sense, ne? I am on the wrong live. Why is that so? Why are you saying babe Dollar is saying I'm on the wrong live? Which live were you supposed to be in? Okay, angle USR. So angle USR is equal to 47 degrees. We can say that confidently. It's equal to 47 degrees. And the reason why we say that, alternate angles, there are lines that are parallel. The horizontals, actually, the planes, they are parallel. That is parallel to the base. Okay, so it's fine if you just say alt angles and then we just write parallel lines like that. So then you can go to a diagram and update that and say that's 47. Now I'm sure you can find the distance of UR, which is the height. Okay. Ne? Surely, ne? We can do so.
Yeah.
Yeah, because we have UR here, we have 50, we have 47 degrees. So what are we going to use in order to find UR? So what is UR in relation to this angle? What do we call this side?
Opposite. Aren't you going
And
to
then what
use
do we call the side that has been given to us?
hypotenuse?
Hypotenuse.
So which trig ratio takes
Sine.
those? Exactly. You see, guys, sine 47 is equal to UR over 50 meters. Unknown is in the numerator. So what do? We cross multiply, not interchange. That's the shortcut. Instead of having to multiply both sides. Shortcut, cross multiply. Take your calculator, punch this in. What is UR? I'm gonna wait for you guys. It says round off to 2 decimal places. That was calculate the height URU of the building, correct to 2
It's
decimal places.
46,57.
46 comma
36,57. 3.
36
Yes, sir. Comma
comma
57.
okay 57. Agreed, Asenat? Okay, Asenat is away. Thirty-six comma 57. Okay, you update 36 comma 57. Okay, you update there for yourself. Okay, so let me just extend this and just sort of like include it as part of my diagram. We have T here, that's 38 degrees. Okay, next question. Determine the distance ST between the two people on the ground, correct to 2 decimal places. Guys, how do we find the distance between the two people? In other words, ST.
Shouldn't we use adjacent?
Junior, are you speaking?
No, sir, not speaking.
Oh, okay. Hotato has said something. Asenati, any thoughts?
Samus, we can't use the trigonometry since it's not a right angled triangle.
We can't use the what?
The trig ratios.
Okay, I'm listening. What then could we use? Yeah, so this one needs just a little bit of thinking outside the box, not in the box. Okay, so imagine if you look at triangle URT, you have this angle, right?
Yes.
You have RU, you just found it not so long ago. It's 36,57.
Yes, sir.
You can find the adjacent RT for the entire triangle, right?
Yes, sir.
Yeah. Then after using this right angle triangle to find RT, you will come and use this right angle triangle to find RS.
Yes.
Are we together?
Yes, sir.
Then you will take this full length, which is RT, and subtract RS so that you can get ST.
Yes, sir.
Who's not following me? I've lost them completely. Yeah, when my people are silent like that, I know there's a cause for.
But
And what did
Z,
you hear?
can you repeat one more time?
Okay, so let me just. So remember, triangle URT.
Yes, sir.
You see, triangle URT. We can find RT. Okay, we can find RT. How are we going to find RT? Remember, we have an angle. Okay, we have an opposite side,
Yes, sir.
which is UR. We need the whole adjacent side.
Yes, sir.
Are you with me? So in triangle URT, we say sine of 38 degrees
Yes, sir.
is equal to, sine of 38 degrees is equal to UR, which is 36,57, divided by RT, the whole entire length of the whole triangle. Are we
Yes, sir.
together?
Yes.
Then what do? We interchange. Not cross multiply, but interchange. RT replaces sine 38, sine 38 replaces RT.
Yes, sir.
Okay. Sorry, this is not degrees, it's meters, divided by sine of 38. Grab your calculator. What do you get? Oh, it's not sine. It's not sine, it's tan, guys, right? Did you see that? My mistake. Tan. Thank you, Ellen. Tan of 38. Opposite over adjacent. Not opposite over hypotenuse. Opposite over adjacent. Thank you, Ellen. It's tan, not sine. Okay. Okay, so let me just rewrite that again. Thank you, Ellen. Tan of 38 degrees is equal to UR over RT. UR, as I said, we got 36,57
Yes, sir.
tan 38 over RT. So sorry guys, that was my mistake, big mistake there, but Ellen really helped picking that up, because even me, I think, it's not, I didn't check there. The definition of this angle is equal to the opposite side over the adjacent. So OA means tan. Tan of 38 is equal to 36,57 over RT. So we interchange 36,57 over tan of 38. So we put that in the
I got
calculator,
to
and it should give
46,8.
46,80.
1.
Okay, 81. But guys, since this is a problem in progress, I am going to be interested in the raw value when I calculate the distance at the end. I don't want the rounded off value, because the rounded off value is obviously tampered with, but I will need, or I will utilize the raw value rather. So I got RT. Now what's left is for me to find RS, because it's for this right angle triangle that I have where I can find. So I'm going to say tan of 47 degrees. Remember, this triangle here has this angle 47 degrees. Tan of 47 is equal to opposite, which is UR. UR is 36,57 over RS. Okay. Then we do what, guys? Yeah, at this stage, the unknown is in the denominator, so we
Cross multiply.
interchange, right? For shortcut. RS replaces tan 47, tan 47 replaces RS.
RS.
Yeah. because that's the shortcut, guys. We cross multiply if the unknown is in the numerator. But since the unknown is in the denominator, we interchange tan 47 and the unknown with tan 47. What do you guys get? 36,57 divided by tan 47?
It's 34,1.
1.
1, just 1.
34 was unique.
Sorry?
Why? It's nothing.
Okay, just verifying it here. Yeah, 34,1. So we'll say just say 10. 10 meters. Then I said what we have is this entire distance from RT, ne? And we just now calculated from RS that distance. So we want the balance, okay, the distance between ST. So what we do is we take RT, so we say ST is equal to RT minus RS, okay?
Yes, sir.
So mean,
Nothing, sir.
have I lost you?
No, sir.
Are you sure, guys? Like, please do say so.
Sir.
So can you see like the drawing again? I want to see as ST.
Yeah. So RT I got, ne?
Yes.
Yeah, which is the full length. I then got RS, which is just the portion.
Yeah.
So now I want this one. So I take the full length minus part of the
Minus,
length.
yeah.
Should give me the balance. So that's why I say ST is equal to RT, the big length, minus a part, which is RS. Okay?
Okay, so
But remember, I said I want the raw values, not the rounded off, because I only round off at the end. So what I'm going to do is I'm going to write down those fractions, the trig ratios, and subtract them, because this is the actual length of RT and that's the actual length of RS. Okay, I want to get the raw value and round off. I want to round off the final answer to the actual decimal place that has been stipulated, not these answers. But I mean, I can temporarily write those answers. RT is 46,81 meters. RS is equal to 34,10. But ultimately, I want to take the raw values of each length and subtract them so that I can get the rounded off value at the end, which is correct. So what do you guys get?
two. It's 12. Total is 12,705388879.
Oh, sorry, say that again. Didn't hear that.
The total was I didn't take the
12,
of ones, I just did it again. It's 12,705388879.
Okay, awesome. Which means it's 12,71 meters. Ne?
Yes.
Yes.
Yeah, so that's the final answer, and that's where the journey ends. Okay.
Yes.
Yeah. So guys, yeah, I think so. Once again, I think I'm not going to drag it out, but I'm going to leave it here. So please, guys, remember, we have obviously the equations and solving for the equations. Let's remember how we do these ones. I think we did quite a few yesterday as well. I think we got our
Yes,
practice.
Euclidean now.
Yeah. Yeah. So yes, the time does need to be given at some point of the Euclidean. Mike, wait. Just let's check again. When is Asenat? When did you say you're writing, Junior? Asenat?
The 17th.
Oh, 17th, which is Wednesday. But aren't you writing analytical and trig when Asenat?
So okay, clean is about corner because like it was the topic that we like did the most.
Oh, okay. I didn't know that. Okay. Okay, then that means unless you guys, me, I don't have a problem. We can maybe start trig. I'll do a bit of Euclid just before. Okay, maybe I can nyangeza it now. We can nyangeza it. I don't have a problem with that. I'm always ready to nyangeza Euclid when the need arises. Okay, there we have it, guys. Beautiful diagram. Looks good. We can see, no?
Yes, sir.
Okay. So it says in the diagram below, PQRS is a parallelogram. And we are told that Q1 or angle Q1 is equal to angle Q2. Where's Q1? There's Q1, there's Q2. Both angles are equal. Then they say angle TS is equal to SR. And then angle P is equal to 80. Okay. Now 5.1 says calculate with reason the sizes of the following angles. Angle Q1. What are your thoughts? Angle Q1. Just want to hide that. Those other questions so that we can focus on one question at a time. The diagram below PQRS is a parallelogram. So the minute they say parallelogram, that means all properties that relate to the parallelogram apply here. Everything. That means 1, opposite sides of a parallelogram are equal. That's true here. 2, both pairs of opposite sides are parallel. That's true for this here. 3, opposite angles are equal. That applies here. 4, diagonals bisect each other, but we don't have diagonals here, so obviously there's no relevance in that here. So now they're saying calculate with reasons the sizes of the following angles. Angle Q1. There is angle Q1. What would be the size? And why? Remember, we always provide reasons with Euclidean geometry. You don't just write. There must be a reason and it must be acceptable. So any thoughts? My lovelies? Ellen is saying angle T1 is equal to 8 degrees. Corresponding angles. No. T1 is not corresponding to angle P, Ellen. Remember? For that to be true, this line and this line must be parallel. Right? Then we would say bottom, bottom, or top, top. That's not true. Okay. So Junior Asenati, Potats, or any thoughts at all? Yeah, let's even clear it up like this. Hey, now it's very clear, né?
What's the
No
question?
comment section, no one to interfere.
What's the question, sir?
Sorry?
Can I see the question, sir?
The question is, calculate with reasons the sizes of angle Q1. Q1 is there. Okay, so what did they say here? PQRS is it?
Parallelogram.
Okay, if this is a parallelogram, it means PS and QR are parallel, SR and PQ are parallel. So what do you know about angles between parallel lines?
The opposite angles are equal.
Sorry?
The opposite angles are equal.
Okay, so yes, for a parallelogram, that's true. But what I'm asking now is, what do you know about, for instance, angle P and angle Q? They have a relationship together. What do we call that relationship? Like the U-shape relationship. It's kind of like that. These lines are parallel. What do you know about these angles?
Co-interior, which means they add up.
Yeah, they are
Co-interior, which means they add up to.
co-interior, right?
Yes.
So AD with this entire angle 2 here, we know those angles are what?
1/8.
They add up to 180, right?
Yeah.
Yeah. So if that is 80, what is the entire angle Q?
100.
100.
Yeah, it's 100, right?
Yes.
50%.
So how would you actually then develop that? You would say,
2x.
sorry?
So wouldn't we write it as 2x minus 80 is equal to 180?
Okay, remember, you need to be very careful there. If you are going to say that, then you need to first start at letting, if you are going to say that, you can either let angle Q1 and angle Q2 be equal to x. The reason why you're calling them both x is because, yeah, angle Q1 you were told is equal to angle Q2. Yeah. So you start right there. Okay. So I would say that angle Q1 is equal to angle Q2. That is given, right?
Yes.
Yeah. Then what you could then say is 80 degrees plus Q1 plus Q1. Okay, remember, because you said angle Q1 is equal to angle Q2, that's given. You can say 80 degrees plus Q1 plus Q1. Most you wanted to say angle Q1 plus angle Q2, but because you've already established that the two are equal, it means in the place of Q2 you can replace Q1.
Yes.
Are you hearing me, guys? Then you say that's all equal to 180 degrees. Your reason. Co-int angles. Then you state your parallel lines.
PS is parallel to QR.
PS is parallel to QR. Because you must state those lines that are parallel whenever you use co-interior angles. Okay.
Yes.
So then you do the maths. 80 degrees plus 2Q1 is equal to 180. You isolate angle 2Q1, 180 minus 80 That gives you 100. Then you divide both sides by 2. Angle Q1 is 50 degrees. Okay. Yeah. These are the things, guys. Okay. For Euclid. So Euclid requires you to see even the things that don't seem too obvious. So as I said, the statement itself, when they say in diagram below PQRS is a palm, then it means everything that relates to a palm is going to be true. Okay.
Yes.
And we then need to relate it to the diagram that we have so that we can get the next and the next angle.
Yes.
Yes.
Yeah. Guys, I think I'm going to continue with the geometry tomorrow, of course. But I think I'm going to hold it right here. Okay. Yeah. Maybe what I can do is I can leave the rest of the question. You guys can screenshot this. You can do the rest of the question on your own. Then when I come and do the live, we can actually just look at it and finish it and complete it. So let's just do that. You screenshot that. I'm sure I hope you've screenshotted that. Here's another one. Okay. Screenshot. Okay. And you can see the concepts of what? What does that 3 lines mean there, Junior?
Congruency, sir.
Yeah. You see, proving congruency, proving lines are parallel, and proving that a quadrilateral is a parallelogram.
Yes, sir.
Okay. And then also proving the equality of 2 adjacent sides. Very important things there that you need to know.
Sir,
Yes.
are they going to give us an information sheet?
They should. Like you can see here,
But that
they
information
should.
sheet doesn't help me. Why? Doesn't
Yeah,
help
that
with
means,
anything to me. Even in physics.
yeah, but look, analytical geometry, at least you have the midpoint, you have the gradient,
And the distance.
yeah. So, but the rest, that's the thing, you need to know, man. You need to know formulas, man. It's your responsibility as an art. Yeah, guys, I'm gonna call it a night. I'm sorry that I have to kind of cut the live short, change like that, but I think we've done quite a mighty bit today, and also like hammering in those
Yes.
things. Yeah,
tomorrow
guys, I do want. Huh?
Because tomorrow we must fight. Because 17 is gonna kick us.
You're starting to speak in that nonsensical negative way. Asn't that?
No,
You are starting now. It's gonna kick us. You are already declaring defeat if you are going to speak like that already before the main event. Yeah. Now as an I can see it's that same mindset that those Bafana players they entered into when they were playing against Mexico. That's why they got kicked.
Kalok said if we don't practice, Kalok, like if we don't do it tomorrow, we'll like see then
Yeah, but
we must make sure tomorrow so that land.
I must say, yeah, but also you must also practice, do your part. I mean most you guys have been taught this thing, so it's a matter of also like just doing your part and making sure that you are sorted. Okanye, do you guys want us to at least finish this one together? This one.
Yeah,
We can just do it on our own, then like
Okay. Do it on your own then. But what I'm saying is that guys, let's you must push there on your end, and then we'll definitely be doing Euclid more and more of it tomorrow.
Oh.
Yeah.
Okay, let's go tonight. Bye, sir.
Okay. Yeah, and guys, I do want to, let me just think it would be appropriate, I think, to just, oh, I need to get rid of you guys first. Let me get rid of all of you. I can't show this thing now because all of you are here. Bye-bye, bye-bye. Bye, Junior. Bye, Zanati. Bye, bye. 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 Hotels, bye. Okay. Guess I need to change my settings as well. Now I can't even. What's happening? Yeah, so this is what I wanted to actually show, guys. This thing here. So yeah, this is what I said I wanted to cook for this coming, what is it, this coming, yeah, because during the holiday time I actually want to just go over term 1 and term 2 work, but like strategically. So there is like unlike these lives where maybe there seems to be a little bit less structure or something like that, but there is a structured, pre-planned sort of like you could say term 1, term 2 mop-up session that I want to do from the 22nd to the 5th of July, right? So from the 22nd to the 5th, 22nd is next week, Monday. Yeah. So from the 22nd to the 5th of July, I'll be doing a term 1 and term 2 mop-up session, which means basically I'm going to be hosting sessions where I'll be just doing term 1 and term 2. But this is going to be with a specific group of grade 10 learners that are interested in actually doing a mop-up session that is structured in that way. What is the intention? It's to close gaps, guys. Term 1 and term 2, whatever gaps you may have had in term 1, right, and term 2, that could be from anything ranging from numbers, your numbers, set builder notation, interval notation, what else is there? Expressing rational numbers in terms of a fraction. If you have recurring decimals, expressing them as a fraction, indicating between which two consecutive integers a particular irrational number lies, and other number system related questions, identifying integers, rational, irrational, non-real, and all of that stuff. So basically everything related to that section of the number system. We are going to be looking at subsets, sets, and the works, rounding off everything basically that's there. Simplification, algebra, all of algebra, okay, your addition, your subtraction, multiplication, division, binomial, binomial, so basically everything there. Equations, exponents, right? Simplification of exponents, addition, subtraction, the works. Equations, addition, subtraction of equations, solving for equations, quadratic equations, linear equations, literal equations, word problems, simultaneous equations, word type problems, equations. Okay. What else is there? Yeah. All right. So basically a mop-up session of that nature. Then there'll be work given to those particular individuals, the ones that are basically obviously going to be part of the program from that 22nd onwards. Then there'll be work. I'll have a WhatsApp group. Those learners will have an opportunity to have work sent to them. I'll be requiring them to actually send me that work so that I can actually mark it, So I'll actually be checking if what is being taught is actually being understood and if you guys are actually getting, so that the mop-up can happen genuinely, not just like me teaching you and then not knowing how you do the work. All right. So there's going to be a level of honesty that I'm going to be expecting from you guys, that if I give you the work, you don't touch AI, you don't ask for any intervention or help from anyone else. You do the work, because when I teach or when I go through the sessions with you, it should be your sort of like main responsibility to ensure that we don't leave a session with you still confused. You can't be doing that same thing that maybe you've been doing at school, where you allow a lesson to just be done and finished and you are lost completely. You can't be doing that. All right. This is your chance now to sort of like, for once and for all, really get the content that you've covered in term 1 and term 2 for your mathematics. Why, guys? Because remember, you want to have a solid foundation for your maths going into term 3, but not only term 3, for the end of the year when you write your final grade 10 exam, your provincial papers. Because rest assured, guys, if that confidence is not there, or if that is not there, what's going to end up happening is that you're not going to get good marks, and it may lead to a sense of you being despondent in wanting to even carry on with mathematics in grade 11. And that can't be the case, all right? Because remember, guys, mathematics is a doorway. It's an important subject. It opens up opportunities. So you can't just settle for mediocre with mathematics. You actually need to really just do well and excel. So like I said, guys, that is from the 22nd to the 5th. Then obviously there'll also be the term 2 work that I'll be covering as well. And with that, I mean your Euclidean geometry, your functions, your trigonometry, your analytical geometry. We will cover those topics and cover them thoroughly, so that as I said, work can be sent, you guys can do it, and you can see if you actually understand. And yeah, we cover those, we mop up, we cover those gaps, right? Yeah. And like I said, to a large degree, it will be a lot more work that's going to be required for you guys to do, so that you can then take pictures, send it to me, I can mark it, and I can forward it back to you, so that you can see where it is that you are getting things right, where is it that you still have gaps, so that those gaps can be officially just closed. Then from the 7th to the 30th, I'll be doing term 3 work. If it so happens that maybe in those days from the 22nd to the 5th, there are still things that are sort of like not covered still, then what we will then have to do is we'll have to use some of the days from the 7th to the 30th, maybe just a few of them, to make sure that we are covered for term 1 and term 2. I hope that makes sense. Then from the 7th to the 30th, we'll do term 3 early, before schools reopen. We will cover, complete, and do term 3, so that by the time you go to school term 3, you already know what is popping with the mathematics when you go into term 3. Because there's no other thing that you must do with term 3. You must just excel and do very well in term 3, so that becomes a confidence booster for you to get into term 4, write your final exams, and at least when you go and write those final exams, even when they do a revision of term 1 and term 2 work, when you will be covered, because at least during these winter holidays, you had already started some form of sort of like mop up and making sure that you cover your gaps, then it won't be too much to actually cover for your final exams. Okay. So guys, with that said, you can imagine then that there's a lot of work there. There's a lot of preparation that's going to go into that. And also a lot of work I'll be doing as far as making sure that when you send me your work, I mark your work and send you back the feedback. Because maybe even at school, you don't even get a chance for your sir to actually mark your work and give you feedback immediately. So it would kind of like be important for the feedback to be given to you guys sort of like as soon as possible, ASAP. So I'll be making sure that that does happen. Yeah, so that whatever mistakes you can know immediately, okay, I have an error there and I need to fix there. So this is just for the grade 10s, guys, right? This one is primarily focusing on the grade 10s. Yes, there is a cost attached to that thing, as you can see there on the screen. Okay, because for that entire period, all right, because this is just for it's not, I'm not going to generally have everybody go through this. It will be for the exclusive group that actually decides to actually be part and parcel of this, Okay, so at that price there, as you can see, it's 350. Okay, if possible, payments can be made before the classes begin, but if not, I mean, guys, we can actually like give leeway for until the end of the month of this month. Okay, and of course, if like there's a commitment that, okay, no, so we'll be paying later, you can always obviously talk to your parents and then see if they think this is something that would be beneficial for you. If so, then great, then we can hop on and do this thing. All right. I'm happy also to kind of like give you my contact detail. You can DM me and let me know if you are interested and if that's something you'd be interested in. I'm just thinking in the event that maybe a parent wants to actually talk to me directly and find out about this thing and details and so forth, then I can actually communicate directly to your parent and I can let them know about this particular thing. So yeah, guys, you must go and sit with this, think about it, and then you guys can come back to me and let me know. Please, if you maybe possibly are feeling like, no man, I'm good, sir, I'm sorted, I don't really need anything like this, I think I can actually go my own way, then that's fine. But if you can share this with maybe your friends and all of that, you can screenshot this, send it to your friends and share it. I will be posting it on my TikTok page as well for those that may potentially be interested, so that they can actually also see this. And yeah, guys, officially I'll be having this going on as from next week, Monday. Yeah, I will be running it on TikTok, but the thing is, I will be limiting my guests to the people that have actually indicated interest in this thing. So the live lessons will be running, but I will actually limit those live lessons to the people that have indicated interest in actually being part and parcel of this. And also the group on WhatsApp will only be exclusively those people that are actually the people that have indicated that they want to be part of this. So that's just it about this particular thing. So I hope those who are interested, please do let me know, DM me, contact me, let me know. But also, please, if you can, share it with your friends. I know there's individuals that probably do need something like this, because maybe some of you, when you wrote during your paper one or the exams this term, you actually realized, hey, there's a few gaps that I have. And the whole purpose of this thing is to make sure that those gaps, we actually literally close them off. So it would be good, for instance, for some of the people that are really interested to actually go even to your teachers. If, like, let's say, for instance, you've written already marks, you've already gotten your marks, go and find out from your teacher, like, specifically where did you go wrong? What areas does your teacher think you need to improve on in preparation for possibly your final exams at the end of the year, so that your teacher can actually give you pointers or give you tips or give you an indication of where he feels that you still need to work on. And then maybe even in my in the time that we have these sessions, you can bring those areas through or bring those areas up so that we can also actually genuinely cover those areas. All right. So that you guys can be prepared for the upcoming term and also for the end of the year final exams. Yeah. So guys, that is just something I wanted to let you guys know and announce, so that you know that there's something of this nature. Okay. Otherwise, food for thought. Please go and think about it. Go and share it with your folks, and let them know. If you are interested, to let me know ASAP as soon as possible. And like I said, I'll be happy to actually give you guys my contact details if you let me know privately, so then I can we can get in contact. Okay. Otherwise, guys, I think that's it for today. And now I will see you guys tomorrow to just finish off the Euclidean geometry. And just do final touch-ups for your guys writing, whether you're writing on Wednesday or later on in the week or next week. Yeah. Otherwise, let me love and leave you. I hope you guys have a great one, and I'll see you again tomorrow. Cheers.